Hi, everyone, and welcome back to On the Right Side of History with Kansans for Life. I'm Danielle Underwood, your host. In today's episode, we're talking science. Nearly every day brings word of new breakthroughs in science, medicine, or technology. Now, with the rise of artificial intelligence, we've entered a phase of lightning-fast advancements with lofty promises of great cures. Where are we heading? And are all of these innovations good? Here to help us unpack this topic is Dr. James Sherley, an Ivy League-trained molecular biologist, researcher, entrepreneur, and former professor. Dr. Sherley is an associate scholar at the Charlotte Lozier Institute. He's also the founder, president, and CEO of Asymmetrics, a company working to ethically advance technologies in stem cell medicine. Dr. Sherley will introduce us to his next big project in today's episode, so you'll want to stay till the end. Thank you, Dr. Sherley, for joining us on today's podcast. We're excited to have you here, and I was blown away just reading through all of your list of credentials in your bio. You are a man who has done so many things and been so many interesting places. So you are a very accomplished scientist. You're a Harvard grad. You earned your MD and your Ph.D. at Johns Hopkins University School of Medicine. You did your postdoctoral studies in cancer biology at Princeton, and you were a member of the teaching and research faculty at MIT. And I'm just wondering, you've seen the inside of the top levels of academia, but you believe that in some sense, modern science has lost its way. And I'm wondering, how has science gone off the rails?
Yeah, so, the way I think about the sort of ethical issues with science and how it engages with the rest of our society, off the rails isn't new. It's sort of always been that way. We can go way back even to the 1800s and see how science, the knowledge that scientists find about the world, can get misused by others. And so there's always been a need for ethics and morality in terms of evaluating what we do with the knowledge that we gain. So this isn't really a new problem. It's a continuing problem. And, the way to think about science, sometimes people think, science is just this really pure discipline. Science is only as pure and moral as the society in which it operates. And so, because scientists are who? They are members of society. They bring to their work all of the prejudices, the problems, the abuses that we do in other parts of our society. Science has this feature of being objective and having quantitative measures for figuring how well something is known. But ultimately, the way I think about science, we have to always ask the question, is it injuring anyone? And is it being used to injure anyone? And that's when science is off the rails.
That's a great point of clarification. Can you think of any examples that you're seeing today about how science is being used or misused, I should say?
Yeah, so one of the areas where I spend a lot of I call it public service effort, is in the area of how science wants to use nascent human beings. And what I mean by nascent, our human beings in our earliest forms, when we're embryos, when we're in our fetal stages. And that's like a continuing tension over scientists who say we want to study the earliest forms of human beings because we can do more and better things for more advanced and more mature human beings. But in the process of doing that, nascent human beings are being destroyed and injured. And those injuries actually extend out into our greater society. So I think that's one of the greatest areas we have right now where knowledge and understanding is really in competition, if you will, with how we're treating individuals, how we're treating nascent human beings.
And how do you see that playing out in specific areas of science? you see that. I'm assuming you're talking somewhat about stem cell research on embryos. Are there other things too that you would point to as specific examples of this?
Well, I think there probably are some areas, again, related to that are in the area of nascent human beings that the public probably isn't aware of, that me and my colleagues are concerned about. 2001, when I really got involved in the public service work that I do now, was when it was possible to take human embryos and make what are called human embryonic stem cells. And the controversy around that is because in order to make the embryonic stem cells, which there was a lot of interest in research, and maybe there were going to be new medicines derived from them, required the destruction of an embryo. And at the time, I think a lot of the public didn't understand how was an embryo a human being. So there's been a lot of education around that. So, but those were essentially natural embryos. They were being made by taking human eggs and human sperm, something called in vitro fertilization. You get these very early nascent human beings. But now, many of the public doesn't realize that scientists have learned how to take the stem cells and make embryos. And that research is motivated by the very utilitarian nature of science, that we're doing this because we're going to get something better from it for someone else, right? So that activity is going on. There's actually quite a bit of debate of it in the very, in the halls of science, if you will. But I think the public isn't aware of this. And so one of the things that is really, that I've been engaged in, is trying to do two things. One, when the public hears about some new development that involves injury to nascent human beings, is letting them know that's happening. But the other thing to do is to alert them that there are new scientific activities taking place that involve nascent human beings that they weren't aware of.
Interesting. Is there any kind of science that's being done that's trying to blend the human genome and other species? Is that happening now?
I'm glad to say that that's in our past.
Okay. Well, that's good to hear.
There was a period during the early years of the embryonic stem cell debate when scientists who wanted to make embryonic stem cells were looking for ways to do that might be considered acceptable by the public, or by persons like myself who said we shouldn't be doing this research. So they came up with two ideas. One was, why don't we use our technology to make nascent human beings, embryos, that won't live very long? So we can study them for a small period of time, and then we can let them die, let them self-destruct. At the same time, that group of scientists and some others as well were saying, well, gee, maybe we can make embryonic stem cells that aren't from embryos that aren't really human beings. And the idea was to take the nuclei of human beings, which is what we want to study. That's the DNA that contains this part of the cell that contains the DNA, and put it into and so the problem was the way you make these, there are two ways of making embryonic stem cells. So I told you already about doing in vitro fertilization, getting an embryo, and using those cells to make embryonic stem cells. But the other way you can do it is to take an oocyte from a woman, an egg from a woman, remove the nuclear DNA there, and take a nucleus from another person, put into that egg. And that's called cloning. You get an embryo, and then you can make embryonic stem cells. The problem with that is that you have to harvest those eggs from women. And that process can injure them, can leave them with health issues. And so they were looking for a way to make the embryonic stem cells without having to harvest eggs from women. So the idea was, let's harvest eggs from animals, from cows, from sheep, and take human DNA, put it in, make an embryo. And the thing about these types of ideas is that scientists who know this area of scientific investigation understood that that was probably never going to work anyway. But the ethical moral discussion was, what was the creature that had been made? Whatever that creature was, this research was going to do the same thing. Destroy, use it, and then destroy it. Mm-hmm. And I think that is the moral problem when we make organisms with the purpose for killing them, mm-hmm. for research that would benefit us. So again, that's a long response to that was a real thing that was happening. They were called chimeric embryos. Fortunately for humanity, they were not successful in making embryonic stem cells from them. So that approach was dropped. Mm-hmm. As far as I know right now, there aren't any of these sort of intentional chimeric organisms being developed.
Okay. Not even in some place like China, perhaps, or other places where it sounds like some of the ethics that guide science here are not necessarily in place in some of those other countries.
So here's the thing about this type of science at this level. It's always utilitarian, right? So if it turns out there's no utility in doing it, generally speaking, scientists don't do it, right? Especially when you're talking about biomedical research, mm-hmm. Where the goal is to find either a better understanding of the human body or better ways of treating human disease and disorders. So as soon as an approach that is disturbing isn't providing any utility, the research community drops it. So
Is that true? Is that true in embryonic stem cell research versus adult stem cell research? Because I know that quite a bit of your work has been in adult stem cells, because you've seen that has been an effective way to address some different illnesses and things that you might be able to treat with that. But it seems like the push to use embryonic stem cells has continued, even though, if I'm right, I don't believe there's ever been a single cure that's come from any kind of embryonic stem cell research. Is that right?
The embryonic stem cell research story has an interesting trajectory. So the scientists who promoted it basically said, we have to do this because we're going to be able to take these cells and make any tissue that a person needs, replace any tissue that a person needs. And that statement turned out not to be true, right? And it ended up not being true in a way that actually nobody had anticipated, right? And the way it's not true is this. It's based on what scientists had done in mice. So they make embryonic stem cells in mice. In that case, you could actually use those cells to make mice. And what they learned in doing that is that the engineered cells that they had made, the mouse embryonic stem cells, could be found in all the tissues of the adult mouse. And that's the basis for the statement that is the basis for the statement that embryonic stem cells can make any tissue in an animal. Right? You cannot do that experiment in humans, right? Even with all the stuff that we do, no one is going to engineer embryonic stem cells from human cells, put it in a human embryo, make a baby, and then ask, do we see a representation of our engineered cell in all of the tissues? So scientists assumed and promoted the idea that that was true, right? The way therapy happens with embryonic stem cells is you take the cells, you grow them, and you make the tissues that you want to put in a person. You cannot put the embryonic stem cells in a person. Everybody knew that. They make tumors. So what science said was, well, what we're going to do, since we can't actually show that we can make every tissue in the body, we're going to make these liver tissues, heart tissues, muscle tissues in vitro. We're going to take the embryonic stem cell and turn it into these adult tissues. And then we can treat the people with these adult tissues. The problem is that they didn't anticipate, and we now know, is that you can't do that. it's very, very difficult to get embryonic cells to make mature adult tissues. They have no problem making tissues that are found in the fetus, embryonic tissues, because that's what they're evolved to do. So that strategy it hasn't worked. And what happened with this, so now they realize, oh, gee, we can't make every cell in the body. We can actually only make very early cells. And we need mature cells. And that brings us back to the cell that has evolved in our bodies to make mature tissues continuously. And those are adult stem cells. There still is not a lot of work and effort into adult stem cell research, despite what I just described. And the reason for it is this. So there's a very, very amazing scientist, Shinji Yamanaka, who looked at the problem with embryonic stem cell research and said, we have to have another type of way of getting to these cells that can make every cell in the body without destroying embryos. And he came up with a way to take mature cells from our bodies and make cells that are very, very much like embryonic stem cells. Okay. And the whole world now of science is doing what's called induced pluripotent stem cell research now. It is everywhere. It's a huge industry. And it's really interesting how science evolves. We still are not going to get to these mature cells from those cells. Now, I want to qualify this myself because there are two clinical studies going on right now that take not embryonic stem cells, but these very similar cells, and they do the same thing. They make mature tissues. And those mature tissues are being tested now in diabetes making mature pancreas cells, what are called beta cells for diabetes. So there are two studies going on right now for that. But there's still a problem, even with those.
So you would say that that is not ethical, or it is ethical research, just to be sure that I'm clear?
With the induced pluripotent stem cells, no person is being injured for that research, because you can take donor cells with people's consent. But there is an ethical issue if we know we have a technology that isn't going to give what we're promising, and we make the promise anyway. And so a lot of that's happening with induced pluripotent stem cell research right now. And I want to be, again, fair. Since we're not injuring anybody to make those cells, it is the nature of research to not know whether it's going to work or not. And so there is a possibility using induced pluripotent stem cells to make some of these mature cells that can be used. And that's the example I gave with the diabetes and the pancreatic cells.
And no embryos are harmed. So no very young humans are being sacrificed for this science. So that is progress in the right sense. Very interesting. Yeah. So you left academia and you became an entrepreneur. Why did you make that change?
Because they wouldn't let me stay in academia. I say that with a smile, but it's one of the hardest things that's happened in my career. I ended up not getting tenure at MIT. It was not about my work in areas of ethics around embryonic stem cells. It was basically because we still are in a very racist country, and there was a lot of racism in my tenure case, and I ended up not getting tenure there. I then moved to another institution. I had a wonderful time at Boston Biomedical Research Institute. But Boston Biomedical Research Institute underwent a financial failure after 46 years. And what I found out at that time, when I needed to go to another research institute, there were two things that kept me from going. One of them was my work in the ethics of embryonic stem cell research. That's clearly a part of it. Could not get a new appointment because of my position on that. And then the other was the protest that I had launched at MIT regarding the denial because of racism. Mm. So I suddenly found myself unable to get a position. And I had been planning to start a company to pursue the types of technologies we were developing for adult stem cells at MIT. I had been working on it with lesser intensity at Boston Biomedical Research Institute. And when I couldn't find a position, I thought this would be a good time to start that company. And at that point, I became reluctantly a bio entrepreneur. And now I have to say, after 13 years of it, it's been a good change for me. I've learned a lot of new things, and it's allowed me to continue to do what I really think I was born for, which is to be a scientist.
And what freedoms do you have in the entrepreneurial space that you didn't have before?
Well, it's a very different world than in academia. As I like to say, when it comes to having discussions with people about business, unlike in academia, they're only talking to you if it makes sense for them, right? So it's a much easier space to negotiate in that sense. But on the other side of it, I think when I was primarily an academic, I felt like I had a lot more control of what was going to happen. You do a good experiment, you get a result from it. It may not be the result you want, but you can make decisions based on it. Business does not work that way at all. It's a much more amorphous, difficult kind of space to be in terms of feeling like you have control over what's happening. There's a lot of other unknowns, a lot more unknowns, I think, in the business world.
Very interesting. So do you think that for-profit science is helping to solve the problems within science as a whole, or is it compounding it?
It is an essential for the best progress in science.
Oh, very interesting. Tell us why.
Right. Now, I'll tell you, when I was a graduate student, I couldn't even have had that thought. But what I appreciated as I moved through my career is that the way we get scientific knowledge and ideas to helping people is through commercializing them. That is the engine that brings the resources to bear and the motivation to get things that people that are going to help them. So it can't be the only way, but it is really a very, very important way. Drugs that get developed, for all of the criticisms we have of how the pharmaceutical industry works, it is the only way really to get it done. Yeah.
Interesting. I do think, overall, entrepreneurs, they fuel our country, right? So much innovation happens in entrepreneurial settings, and people who are driven to succeed and go out and they start something for themselves because they don't want to be held back, by having a lot of infrastructure around them that keeps them kind of chained to certain things, but it allows them to really move forward in leaps and bounds. I think that's very exciting. So outside of that, you've talked about your the work that you do just to help the common good, essentially. And you have a really important new side project that we were excited to learn about this summer when the National Right to Life Conference came to Kansas City, to the Overland Park area. And you presented there with Dr. David Prentice on the Science Alliance for Life and Technology. And I'm wondering if you could tell us, you are a founding member, so tell us why. Why are you starting this now?
So some of it is there was an opportunity to start it. Everyone who's involved right now, starting with David Prentice, who's our fearless leader, we know each other. We worked on projects together, all in the space of educating on the issue of nascent life research and abortion, right? And some of the founders were previously officers in the Charlotte Lozier Institute. And they sort of had finished their tenure there. I'm an associate scholar. When they were there, we worked very closely together. So we have a great working relationship. And we all have maybe a few things we have in common, but this one we all want to do is to make sure that the public knows what's going on in science that impacts the public in the form of nascent life, and to provide guidance with the education of what that science is, because some of it's very complicated. Even when we talk about it amongst ourselves, sometimes we're confused about exactly what. But we find a way so that people understand exactly what's going on, and then what's important is looking at the ethics of it. Right? The best science is science that's done ethically. And that's not just not cheating in your lab notebook. It's thinking about how what we do in the laboratory impacts people, especially injures people. So all of us have that in common, that we want to be trusted educators of the public about these areas that are very difficult to understand, and to provide guidance on what is ethical science and what isn't. And the way to think about it is, I think about it this way. If we have a process going on and we know it's not ethical and we do it anyway, it's a license to the rest of our world to behave in the same manner. And we're all impacted negatively by that. You see someone being injured and you look and you say, oh, I'm not going to do anything about that, say anything about it. It makes your whole world worse. So we want to remove the victimization of human beings that science can do, so that human society would be a better, more ethical place to live.
That's wonderful.
And so we share that. We have an opportunity to come together now to try to do that in a much more formal, organized manner.
That's wonderful. So what are your goals in forming this alliance?
Yeah, so in some way I've already sort of stated it, in the sense that education about research with nascent human beings, being a source of information about it. So not just putting out education, but being a place where people, reporters, representatives, clergy, the person on the street can come to us to ask, what is this and how should I think about it? And providing guidance on how research can be more ethical, and alerting people when things are happening in the research that are not.
Okay, so you're bringing yourselves together to be this group of trusted experts that the rest of us can come to you when we have questions about science that is kind of weedy and maybe it's difficult for the typical person to understand. You all will be there for resources. And then will you be putting out white papers? Will you be posting this on your website? Will you be just giving a resource point so that we know the pathway to get to reach you all, so that we can ask those important questions, or that reporters can ask those questions, or all of the above? So
all of that's going on right now. We're literally in the middle of setting up our website and thinking about what kinds of forums we want to have there. Being a place where people can come and get insight, education from us, producing papers, producing white papers about topics. So when these new things happen, like a while back, there was this discussion that suddenly happened about in vitro fertilization and whether we should be freezing embryos. Where do you go to find out? Without politics, just about the science. And the way ethics really works is this: you don't tell people what they should or shouldn't do. You just point out, here's the injury that's happened. How are we going to think about that injury, right? And is there a way that we can get to what we're trying to do without the injury occurring? And a lot of what happens, injuries often happen and people allow it because they're not aware that anybody's being injured.
That's a great point.
Right?
Yeah. And what kinds of scientists are involved already in this project?
Let's see. I think we're all biologists. Just thinking through. We're in different areas of biology. We all are probably in the area of reproductive biology, stem cell biology. Yeah.
Well, that aligns perfectly with our interest, which is all things related to life issues. That is very pertinent to our work. And then are there other types of scientists that you're hoping to attract? And are you kind of giving that open door, signaling to others, we welcome more friends to join us in this effort?
So, Danielle, that is a great question. And I think the way to think about SALT, and you notice that we spent a lot of time thinking about that name. We knew we were about science. We knew we wanted to be allied together. And then we knew we wanted it to be about human life. But technology was the last thing we added. Because the thing is, in human societies, technology is what human beings do. It's actually what makes us most human, is that we can change the world. with our minds and with our hands. And technology is just going. And there's a need to check it, not just in biology, but in chemistry and in physics. So we want to be a model for scientists to better inform the public about what they're doing and be a source of apolitical information and have, overlooking that, a guidance for asking about the ethics of what the science is doing. We don't want to find ourselves like we were back in the 1800s when some scientists were saying they're different species of human beings, and therefore we can hurt those guys because they're not as good as we are. Louis Agassiz in the 1800s, right? We want to be that group that you can come to and say, is this really right, what we're hearing? And sometimes it's just about getting the facts right. And then other times it's about the facts are right, but I like to say, how should we think about them? And is anybody being injured? And if someone is being, and sometimes it's not even someone, something is being injured. So again, we hope that we can be a model for other disciplines in science to do the same.
Yeah. And then I'm going to throw you a curveball here. Artificial intelligence. How does that play into this larger discussion? How does that affect what you're doing? How does it affect us all?
I'm so glad you brought that up. Because I tell you right now, in all of the biology that I'm doing, that is a real central question. And there's so much noise about it right now. There's a lot of injury going on around AI. And I don't think there's anyone, so as I like to say, there's AI happening that we're not aware of. It's been going on for a while. Most of the discussion now is about the AI that we are aware of. Are we going to incorporate it into our work, into our education, into our teaching, all of that? But I haven't heard any ethics of AI other than people say, oh my God, I'm afraid it may hurt me. It's misrepresented. But in fact, the biggest problem with it is like I was saying about science. It's the society in which it operates that it reflects. So I think it would be great to have a group. I mentioned, chemistry, physics. How about information? How about computation? How about computerization? So again, I think that the public could really benefit, and we're not that group, a place where they can go and say, what exactly is this AI? Mm-hmm. And exactly how is it impacting people in my society right now? And when I do get to vote about it, how can I inform my vote?
Yeah. I think with your name, you could make a case that if there was someone who was an expert in technology, and especially in that technology, that they would really fit well underneath your umbrella of the Science Alliance for Life and Technology. I think you make a great case that it is affecting us all, and maybe in ways that we're not even aware of yet. But it certainly will continue to be an important discussion as we're going forward, and as it is integrated into all of these sciences. How is it going to speed up some of these pursuits that people are that people are investigating through science, and how will that affect life? So it's going to be a very important topic, and I hope someone will reach out to you and say, I would love to join you and bring my expertise.
That would be great.
Yeah. Okay. So just on a positive note, what medical challenges do you think ethical, life-affirming science can help us solve in the coming years? What do you see on the horizon?
Well, when you look at medicine, I'm trained as a physician, but I haven't actually done any medical care in some time. But if you look around, the problems that we had 50 years ago are still with us, right? They're the chronic diseases. They're the diseases of children. So I think in general, if you just sort of look at the disease landscape, there are just many opportunities to be able to make contributions where science can help reduce the amount of human suffering. But then there are other things too where science can help that are not medicine per se, but is health. right? Kids getting good nutrition, kids having good places to live. And so again, thinking about how science ethically done can actually help in those areas is definitely something that I spend quite a bit of time thinking about how we might contribute to that. So
wonderful. So what is next for SALT?
Well, we got to get our website up and running this year.
Okay.
And the other thing that we are discussing, I think I can talk about this now, is no one can benefit from you if they don't know you exist, right? Whatever we have to offer, we have to make sure people know we're here. Website is one thing, but we're also thinking now about various events that are happening in the country where we might be present to let people know that we are available to them. Those are the main things. Get communications. I think in one word, it would be communications.
Mm-hmm. Yeah. So you're looking for invitations to come and present at different conferences and places that you might be able to get out the name, Science Alliance for Life and Technology. And then, assuming that people will go back and watch past episodes. I know that your website isn't live yet. I checked it yesterday as I was getting ready. But when it is ready, they're going to be able to find it at, is it Salt for Life?
Salt for Life, yeah.
And is that SALT? The number 4 life.org.
LIF. Mm-hmm.
Okay.
Yes.
Very good. All right. Well, is there any place else while we're waiting impatiently for your website to go live? Give us a timeline. What do you think? A few months?
A few months.
Okay.
Before the end of the year. Yeah, a few months for sure.
I had no idea how early I was in this. I get to be one of the first people to help spread the word about your alliance. That's pretty exciting.
And we do appreciate that too. Yeah.
I love that. I love it. Well, I hope that you will share this out so that more people will hear about it. Is there any place else that people might be able to follow you now while they're waiting?
Well, you mentioned David Prentice. We both have our own LinkedIn sites, if you will. I mean, certainly my company is busy with trying to develop new technologies that are going to help with adult stem cell medicine, that type of thing. So they can certainly follow me in all the usual places online. And the other place is actually, perhaps you may see things from us at the Charlotte Lozer Institute website as well.
Yes, I was going to suggest that. I know that you're published there, and you'll have different articles that I was able to look through and see some of your writings. You have great takes on some of these very important life issues, and so we're very grateful for you and your bright scientific mind. We need experts to come in and help us all to understand these issues at a much deeper level. So we're also grateful for your strong voice in this fight to protect human life, innocent human life.
Thank you. Thank you.
Glad you were able to join us today.
It's been a real pleasure.
And thank you to all of you who listened today. We hope you'll share this with a friend. Stay up to date with Kansans for Life at kfl.org and on social media, Facebook, Instagram, X, and TikTok at Kansans for Life. Before we go, we want to mention our friends at 7 Weeks Coffee. Did you know a baby is the size of a coffee bean at 7 weeks? Yes, that's right. So if you enjoy good coffee, try 7 Weeks Pro-Life Coffee by clicking the link at the top of our website to try this delicious, clean coffee. They'll donate a portion of the proceeds back to KFL to support this podcast and other great work of Kansans for Life. Until next time, never forget, the pro-life movement is on the right side of history. Stay strong. The truth will overcome. Thanks, friends, and we will see you soon.